Alright, good day and welcome. This lesson we're looking at trig in 2D. To look at what's the sine rule, its proof, and its two general problems that we test. So, in any triangle ABC, A over sine A must equal B over sine B is equal C over sine C. Or we can invert the fractions and say sine A over A equals sine B over B equals sine C over C. So in short, that's my angle A. The side that subtends that angle A, which is BC there, opposite A, is called or written with a small letter A for the side. You see, angle B is subtended by AC, therefore that small b, side of angle B, and there's C opposite that. So A here is A, B, and C, the small letters for the sides, the capital letters for the angle. So the top one I would use if I want to work out the length of a side. Bottom one if I want to work out the length of a, or not length, the size of a angle. Right, so let's look at the formal proof. Alright, so proof of the sine rule. So we will give you any triangle ABC. And you'll be required to go draw this line AD that you see there. So first we say let AD equal H. So from A down to D, perpendicular, I draw a line. That line is my perpendicular height. So if I use my trig ratios, the sine of B, opposite over hypotenuse. So sine B equal H over C. Sine C there equal H over B, opposite over hypotenuse. If I make H the subject of the formula, you can see that H equal C times sine B, and H there equal B sine C. But H is the same for both of them, the same H. Therefore, I can say C sine B equal B sine C. Right? So, if I divide, I want to get rid of C and B there, so I'm going to divide by BC on both sides. So C sine B divided by BC equal B sine C divided by BC. C and C cancel, so I have sine B over B equal sine C over C because B and B cancel. So they have proved first part of it. If I want to prove any other angle, I'll just change what I call the perpendicular height. So I can draw a line from C to A, make that the perpendicular height, and then I follow the same procedure. Right, but there's two drawings that we test the sine rule. So let's look at the second drawing. So proof of sine rule. Again, we give you ABC. You're going to draw that line AD, complete to make it a right angle triangle. Let AD equal H. Right, and then I'll take note. If I take the whole angle C there, its angles on a straight line must add up to 180. So this angle here is 180 degrees minus the C on the other side. Alright, so again I'm going to start off and say the sine of B here equal opposite over hypotenuse, or H over C. Alright, the sine of C here, or 180 minus C, equal opposite over hypotenuse, H over B. Make H the subject of the formula. So there H equal C times sine B. Remember, we always multiply the denominator away. On this side here, 180 minus C falls in the second quadrant. Sine is positive there, so that simply becomes sine C equal H over B. Multiply the B away, H equal B sine C. Again, equate the two, so C sine B equal B sine C. If I divide by BC on both sides, C and C cancels, and I have sine B over B equals sine C over C. So those are your two ways we will test you to prove the sine rule. Right? I'm going to be looking at two general problems that you need to stand out to. Alright, so first, we can give you two sides and an angle, meaning they have given you the length of BC, 71, and AC, 68, and I give you any other angle. Angle generally is not in between the two sides. So they want me to determine the size of angle A. So as soon as I want the angle, I will write sine on top and the side at the bottom. So the sine of A over A here must equal the sine of B over B there. Right, so always angle and the side opposite it, angle and the side opposite it. There are 4 unknowns there, but 3 of them are given to you. So sine A over 71 equals sine 52 over 68. Get rid of the denominator, so sine A equals 71 times sine 52 divided by 68. So sine A there, if I simplify that, 0,8227 continuing. Now I press shift sign, 0,8227, and the angle A there is 55,36 degrees. So that's given 2 sides and the angle, and we're working out the angle. We can also test it. Right, so in the next problem now, this one, we've given you 2 angles and 1 side. Right, they want us to determine the length of BC. So BC faces angle A. So I first have to find the size of angle A to be able to find BC. So I have 2 angles. We assume you remember 3 angles in a triangle add up to 180. So angle A is 180 minus the 28 minus the 54, which gives me 98 degrees. My reason, angles in a triangle equal 180. So on the length of a side, so A here, because it faces A, over sine A must equal B that faces B over sine B. Alright, so A over sine A equal B over sine B. A there being BC, sine 98 degrees, which I solved there, B being 18 centimeters, divided by sine 28. So BC, if I get rid of the denominator, would be 18 times sine 98, divided by sine 28. And that, if I put it all in my calculator, will give me BC equal 37,97 centimeters. So those are the 2 ways we test the sine rule. We'll either always give you 2 angles and 1 side, or 1 angle and 2 sides. Right? Take note, the angle is never inclusive, meaning it's never between 2 sides. Right? Next, we'll be looking at the cosine rule and its general problems and its proof. Wish you nothing but the best. Bye.